So this is a follow-on from the previous question about partial fractions, but a bit more difficult because it has a repeated factor here. So how do we deal with that? Well, I've made a few prompts here so you can have a go yourself. But first, let's think of a common denominator of all three of these fractions. Actually, it will always be one that matches the one on the answer, x minus 1, x minus 3 all squared. Now let's think, how can we make this first fraction have that denominator? Well, we'd have to multiply the denominator of this by x minus 3 all squared. But whatever you do to the bottom of a fraction, you also do to the top, and vice versa. So you also multiply the top by x minus 3 all squared. So the first fraction becomes a lots of x minus 3 all squared divided by everything here, x minus 1, x minus 3 all squared. I'm just going to call all of this a. Actually no, I'll write it out. So x minus 1, sorry, it's just going to take a little bit of time for me to write out, which is why I didn't want to, but it's fine. Great. Now let's think to ourselves, what do we multiply to the second term to make it have this denominator? Well, we have to multiply both x minus 1 and x minus 3, so that I can have x minus 3 squared. So we multiply that to the top as well, and we say it's b lots of x minus 1, x minus 3. And moving on to the third term, this already has x minus 3 all squared, so to make it match this denominator, we multiply by x minus 1. So again, you multiply that to the top, and it becomes plus c lots of x minus 1. You might notice I combined this into one whole fraction, and the reason for that is because the denominators now match, so you can add the numerators together. And then you can say that's equal to what's on the left hand side, this whole fraction itself, over x minus 1, x minus 3 all squared. Great. And now we can move on to step 2 of the question. Combine, oh sorry, we've already done this part. Step 3. Equate the numerators of both fractions. And the reason we can do that is because the denominators already match, so we can make the numerators match as well. We can say that the numerator on the left hand side, I'm just going to quickly write out, a lots of x minus 3 all squared plus b lots of that. I'm still getting used to writing on this whiteboard, so I apologize if my writing's bad. And that's all equal to the numerator on the right hand side, 5x minus 13. Great. Now step number 4, we substitute in values of x to eliminate terms or to form equations. So let's focus on this part first, eliminating terms. And I'll do this in a different color. So what I meant by that was if you put in x equals 3 into this equation, it eliminates the a term because 3 minus 3 is 0. Same with the b term. 3 minus 3 is 0, so it'll eliminate the b term. So let's put in x equals 3 into the left hand side. That'll eliminate a and b. 3 take away 1 is 2, so we have 2c is equal to 5 times 3 is 15, take away 13 is 12. Oops, sorry. 15 take away 13 is 2. Divide both sides by 2, and that's equal to 1. Great, so we have c equals 1. Let's substitute in another value to eliminate a term. Here we can put in x equals 1, because that'll eliminate the b term, x minus 1 is 0, and also the c term, because x minus 1 again is 0. Now 1 minus 3 is minus 2, all squared is 4, so we have 4a is equal to 5 times 1 is 5, take away 13 is minus 8, meaning that a itself is equal to minus 2. Perfect, so we've got a and c. We now just need the value of b. Now we can't substitute in something to eliminate the terms anymore because there's only a 1 and 3 that can do that. Instead, we compare coefficients of both sides. So, or we can form an equation. I guess we'll do it this way because I've written it here. What I mean by that is you substitute in a value other than 1 and 3 and it'll form an equation for a, b and c. Because we already have 2 of the values, we can just find the other variable. For example, just think of a random number that's not 1 or 3, like 0. 0 minus 3 is minus 3, all squared is 9, so 9a. I'll quickly do the rest. So minus 1 multiplied by minus 3 is positive 3, so plus 3b. And then 0 taken 1 is minus 1, so minus c equals, the right side becomes minus 13. Great. Because we know a is minus 2, 9 times a is minus 18. We don't know b, so I'm going to write plus 3b. And then take away 1 equals minus 13. Minus 18 take away 1 is minus 19. Add 19 to both sides, so we get 3b equals 19 take away 13, which is 6. And lastly, b equals 2. Perfect. Now that we've got a, b, and c, we can just replace these with the values that we found. So we have minus 2 over all of this, plus 2 because b is a positive 2 over all of this, and then plus 1 over all of this, and that's your final answer. If you have any questions, just let me know in the comments. Otherwise, like the video if you enjoyed it. Subscribe because I'll post new videos every single day, and I've linked my email in the description as well, my business email, in case you have any tutoring inquiries. So yeah, be sure to reach out.